Welcome to Episode 49, Security Basics, Threats, and Cloud Model. In this discussion, we examine the core principles that keep information safe in a world of constant change. The modern threat landscape has evolved from isolated attacks into a continuous spectrum of risks, ranging from automated botnets to well-funded adversaries. Cloud adoption has amplified both opportunity and exposure by connecting systems globally and operating at enormous scale. Understanding these dynamics is the foundation of every effective defense. Security begins not with technology, but with awareness, recognizing that every system, user, and process participates in protection. Whether operating in a data center or in the cloud, resilience depends on mastering the fundamentals consistently. The threats may be complex, but the defense begins with simple, disciplined execution. The shared responsibility model clarifies who protects what within cloud environments. In this model, the cloud provider secures the underlying infrastructure, networks, servers, and physical hardware, while the customer secures their applications, data, and access controls. Confusion about this boundary can lead to serious gaps. For instance, a provider ensures storage encryption, but the customer must configure who can read or write to that storage. Misconfigured permissions remain a top cause of breaches, not because of technical failure, but because of misunderstanding. The shared model enforces partnership. Providers deliver secure foundations, while customers build and maintain secure operations. Recognizing this split is the first step toward mature, cloud-aware security governance. Identity sits at the core of cloud security, making strong authentication the first and most important control. Every request to a cloud service involves an identity, human, application, or system. Weak or reused credentials become the easiest path for attackers. Implementing multi-factor authentication, enforcing password managers, and using federated identity systems significantly reduce risk. In cloud contexts, identity and access management becomes both the perimeter and the enforcement mechanism. For example, an engineer accessing management consoles should use single sign-on backed by hardware security keys, not shared credentials. Treating identity as the new security boundary ensures that even if networks are exposed, access remains tightly governed and auditable. Least privilege and role hygiene extend the principle of minimizing risk by granting only the access necessary to perform a task. Over time, permissions often accumulate through convenience or oversight, leaving dormant accounts with excessive rights. Regularly reviewing and revoking unnecessary privileges keeps the environment lean and secure. In cloud systems, roles can be defined with fine granularity, allowing actions on specific resources rather than broad administrative power. Automated tools can flag anomalies, such as accounts never used for weeks but still authorized for sensitive operations. Enforcing least privilege is not a one-time setup, but an ongoing practice of maintaining discipline as teams, applications, and responsibilities evolve. Network segmentation and minimal exposure prevent attackers from moving freely once they gain access. In the cloud, traditional perimeters are replaced by virtual networks, subnets, and firewall rules. Each workload should reside in the smallest network zone that fits its purpose, with strict rules governing traffic in and out. Public exposure should be deliberate, limited to endpoints that must be reachable, such as web front ends or API gateways. For example, databases and storage buckets should live in private subnets accessible only from trusted services. Segmentation transforms flat, fragile networks into layered, resilient architectures that contain potential breaches and preserve service continuity. Encryption everywhere is a guiding standard in modern security architecture. Data should be encrypted both in transit and at rest using strong, validated algorithms. Key management determines whether encryption truly protects data. Managed key services simplify this responsibility but still require sound practices, such as rotation, access logging, and separation of duties. For instance, a company might use customer-managed encryption keys so it can control revocation independently of the provider. Encryption cannot prevent every attack, but it ensures that even if data is accessed improperly, it remains unreadable. It turns information from a liability into a controlled asset, protected by mathematics rather than just trust. Vulnerability management and timely patching address the reality that software ages and attackers exploit the lag between discovery and remediation. Every organization must establish a repeatable cycle for identifying, prioritizing, and fixing vulnerabilities. Cloud environments simplify this through managed services, but responsibility still rests with customers for operating systems, applications, and code dependencies they control. Delaying updates turns minor issues into major breaches. Automated scanning tools, combined with clear ownership and service-level agreements for patch timing, keep exposure windows short. The goal is not perfection, but responsiveness, detecting weaknesses early and eliminating them before they become incidents. Secure development practices bring security into the design phase rather than after deployment. Developers should treat security requirements as non-negotiable elements of quality. This includes validating inputs, handling errors safely, and using trusted libraries. Dependency management is a growing concern because modern applications rely on extensive open-source packages. Each component must be scanned for known vulnerabilities before inclusion. For example, a web application should not blindly trust third-party code downloaded from public repositories. Automated build pipelines can enforce checks, blocking unsafe packages or outdated versions. Secure development replaces reactive fixes with proactive resilience built into every release. Secrets management and configuration baselines protect the credentials and parameters that make systems function. Storing passwords, keys, or tokens in plain text or source code remains a common and dangerous error. Instead, dedicated secret managers or vaults should store sensitive values with access limited to authorized workloads. Configuration baselines ensure that systems start in a known, secure state. Network ports, services, and permissions all predefined. For example, an organization might maintain golden images for servers or containers that include approved settings only. Strong secrets management, combined with controlled baselines, eliminates entire classes of predictable misconfigurations and insider errors. Logging, monitoring, and alert handling create the visibility needed to detect and respond to threats. Without logs, even the most advanced defenses operate blind. Every access request, configuration change, and security event should generate a record. Centralized log aggregation ensures that signals from multiple systems can be correlated and analyzed. Alerts must be actionable, tuned to highlight true anomalies rather than overwhelm teams with noise. For instance, multiple failed login attempts from a foreign region might trigger immediate investigation. Continuous monitoring transforms security from static defense into dynamic awareness, revealing patterns that indicate compromise or misuse before they escalate. Incident response transforms preparation into action when prevention fails. Every organization should maintain a tested plan defining roles, communication paths, and recovery procedures. Practicing through tabletop exercises exposes gaps before real emergencies occur. After incidents, root cause analysis and postmortems turn failures into lessons that strengthen resilience. Cloud platforms simplify certain aspects, such as snapshot-based recovery or automated containment, but humans remain central to coordination and decision-making. A mature response capability reduces downtime, limits impact, and demonstrates accountability to stakeholders. Security maturity is measured not by the absence of incidents, but by the speed and clarity of the response when they occur. Compliance mapping ensures that security practices align with external standards and internal policies. Frameworks like ISO 27001, NIST, or regional privacy laws require demonstrable controls and evidence of effectiveness. Cloud services provide built-in tools to track configurations, audit changes, and generate compliance reports. Mapping technical controls to regulatory requirements saves time and simplifies audits. For example, encryption settings, access logs, and retention policies can directly support compliance documentation. Rather than treating compliance as a separate burden, integrating it into everyday operations ensures that security and regulation move together, reinforcing each other's goals. Culture remains the foundation of sustainable security. Technology sets the rules, but people determine whether they are followed. Building a culture of enablement means training employees to recognize threats, understand their roles, and report issues without fear. Education should extend beyond specialists. Developers, operators, and business staff all share responsibility for safe practices. Accountability should be balanced with support. Mistakes are corrected, not hidden. Organizations that view security as a collective responsibility develop resilience that no tool can replace. Over time, this shared culture turns security from a constraint into a confident capability embedded in every decision. The fundamentals of security do not change, even as threats evolve. Strong identity, least privilege, segmentation, encryption, and visibility form the bedrock of every secure system. The difference between success and failure often lies not in advanced technology, but in the consistency of execution. Basics performed well, every day, across every system, create resilience that scales. The cloud amplifies both strengths and weaknesses, making discipline more valuable than novelty. By mastering these essentials and applying them relentlessly, organizations build security that endures amid change and complexity. Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.